Now, given cost function, you see it here, 2,000 plus 10x plus 0.01x squared. We want to find the average cost function and find its minimum. We want to get our average cost down as low as possible. Now, what do we mean by average cost? It's the cost per unit, or equivalently, just divide the cost by the number of units. Cost is your C of x, there's your cost function, and the number of units is x. So this is the cost of x units. Dividing that cost by the number of units gives us the average cost, which I designate C bar of x. Now, distributing the multiplication by 1 over x through, we get 2,000 over x plus 10 plus 0.01x. Now, we want to minimize the average cost, so we want to minimize this function. How do we minimize a function? We find its first and second derivative. Easily done. The derivative of 0.01x is 0.01, derivative of 10 is 0, derivative of reciprocal x is negative reciprocal of x squared, and then we get, from that, we get negative 2,000 over x squared. Second derivative, well, derivative of 0.01 is 0. The derivative of negative 2,000 over x squared is 4,000 over x cubed. And you can easily verify that. And we note already that this is always positive as long as x is positive. Now, of course, it's negative if x is negative, but you're not going to have a negative number of products. You can't produce a negative number of products. So the number you produce is always going to be 0 or positive, never negative. So our C double prime of x is always positive. This tells us already that our graph is concave up because the second derivative is the rate of change of the first derivative. First derivative goes from positive to 0 to negative at a critical point, giving us this behavior. Okay, well, so our critical points are what? We set the derivative equal to 0, and then this is very easily solved. We've got the details here, but we end up with x equals plus or minus the square root of 200,000 plus or minus 440. As mentioned here, negative x is nonsense, so we check out x equals 400. Okay, we get plus or minus the square root, plus or minus 440, but we just toss out the negative. It doesn't make any sense, doesn't have any meaning. Well, now we've already observed that C double prime of x is always positive. 4,000 over x cubed is always positive when x is greater than 0, and 440 is greater than 0. That tells us that we have a minimum when x equals 440. And the average cost when x equals 440 is found by evaluating the average cost function. So we do 2,000 over x, 2,000 over 440, plus 10, plus 0.01 times 440. And I believe that comes out around 18.4. So we'd manufacture 18.4 of these to minimize the cost of producing them. Now we still would want to go to our model of a demand function and multiply the demand by the price in order to get the revenue and subtract our cost at x equals 18.4 in order to maximize our profit. But right now all we're interested in is minimizing our cost function. And there might be a number of business reasons why that would take precedence over the other. I'm not going to speculate on what they might be because I've never functioned in business. But very useful idea, very useful model.